All right, permutations and combinations. Let's look a little bit about what this really says. Permutations say the order in a permutation is significant. Combination says the arrangement, the order is not important. In a permutation, like the ones that you just did with the teddy bears, once you've chose that bear, you cannot use it again. You can't just poof, magically make another bear that looks exactly the same. It's kind of like if I said, hey, let's put you guys in the room in a line. Once I use one person, Sam, I can't make another Sam. I just have already used that person and there we go. A combination says order's not important, but again, you can really only select it once in a combination. And this one sounds kind of strange, but because my combination would be the same as yours, even though it doesn't look like it, that's what we're saying. So 3 words of your choice using all of the letters. What I'm saying here is that I'm going to make up a word. I'm going to pick any 3 letters in Oaks that I want. So D, C, and E. If you choose the same D, C, E, we can't do it again. So it's like one of us wins and one of us doesn't. So let's try another one. K, E, S. I'm just going to use the last 3 letters. If you chose SKE or EKS or whatever, it's still going to be the same. Can't use it. So now I'm going to pick one more. AOE, using just the vowels. AOE. Let's see if I can type today. There you go. AOE. So again, if you chose those 3 vowels, and maybe you chose it EAO because it's backwards, we cannot choose the same one again. So what happens with this kind of problem is the difference between calculating this, it's still a seat problem that I want to use. My seats are a little bit different. So I've got 3 seats to choose from to fill. And then I'm going to divide out the fact that I can only have 3 seats. So let's talk about that. 3, 2, 1. So what this is, once we start choosing our 3 letters, we have 3 letters to choose from. 3, 2, 1. So if I say everybody write a word with D, C, and E, we have 3 letters to choose from and then 2 letters and then 1. So we really only have 6 ways to arrange this combination. What we have to start with though is 1, 2, 3, 4, 5, 6, 7 letters. So once I say, okay, pick 3 words, 3 letters, you have 7 times 6 times 5. When I multiply this choice out, 7 times 6 times 5, I have 210 choices in total. But knowing that we all can't pick the same letters, I'm going to divide it by the 6. So when I do that, I really only have 35 choices of words. So again, once I say, okay, everybody pick 3 letters, as soon as I start to write mine D, C, E, you can't write yours. So it eliminates the chance of repetition going on, the same combinations. So how many words can you make using all the letters? That's going to do all the letters. So 7, 6, 5, 4, 3, 2, 1. And then what it does is it divides by the use of all those letters. So no matter what, if you look at this, there's really only one DC Oaks that you can make. Ha ha ha. So your 3 3-letter words of your choice, and how many words can you make using only 3 letters? That's really what we're looking at here. That's what's answering it. So this, sorry, I answered up here. I'm going to kind of be quick with this last one because I'm running out of my 5-minute window. I know I should keep these short. So the purpose of this one is that it's explaining that you can use repetition, which is something we haven't really talked about. Repetition meaning you could have CC as your initials. You could have your birthday and birth year, 1010, something like that. None of us were born in 1010, but 2020, maybe you were born out 2020, 2020. So I can use some repetition. As long as you can use repetition, you're not dividing anything out. The order is important, but it's not. So it's not quite a combination and it's not kind of permutation. These are what I call true seat problems. A seat problem says, I know what I'm going to fill in here, and this is how many choices you have. So after you wrote this out, you should have seen at the end how many ID numbers you can actually choose from if you're doing this. Your initials and any 4 numbers. So there are 26 letters in the alphabet. And allowing the fact that your initials could be the same, CC. There are 10 digits to choose from, whether it's your birth year, your birth month, birthday, or any numbers that we want to assign to you. And what I get is 26 times 26 times 10 to the 4th power, or 26 times 26 with 4 zeros. We really have 6, 7, 6, 0, 0, 0, 0. So 6,760,000 combinations. I don't think we're going to run out anytime soon.